Moving on to 10.3b, we talked about parametric equations. We talked about particle motion involving derivatives, and now we're going to talk about motion along a curve that involve integrals. So displacement and distance traveled. Suppose the particle moves along a path in the plane so that its velocity at any given time is through this velocity vector with the horizontal and vertical component of x prime of t and y prime of t. Then the displacement will be given by the vector, the integral of x prime of t, and then separately the integral of y prime of t dt. So the horizontal and vertical displacement are found independently, just like how the horizontal and vertical components of the velocity are also found independently. Okay, so as just a reminder here, displacement is the net change in position, and we can think of that as the definite integral of velocity, okay, where we keep track of the positive and negative values and they cancel out. Distance is the total distance traveled. Think of it as the integral of the absolute value of velocity, which in other words is speed. So integral of speed. So the preceding vector is added to the position at time t equals a to get the position at time t equals b. The distance traveled is basically arc length, right? Arc length is, we learned from last section, is the definite integral of the square root of x prime of t squared plus y prime of t squared. Example 1, an object moves along a curve in the xy plane with the position provided by x of t and y of t. At time t with dx over dt with the x prime, or the horizontal velocity component of t sine of t, the vertical velocity component cosine of t squared. At time t equals 2, the object is at the position 1, 4. So part A, find the acceleration of the vector for the object at t equals 2. So we can create our acceleration vector by finding the derivative of x prime of t and to find y double prime of t. But it's only asking for the acceleration vector at t equals 2, so rather than going through a product rule and chain rule, we can just use our Math 8 n-deriv feature in our calculator and just evaluate the derivative of t sine of t, evaluate the derivative, second derivative at 2, and same with y double prime of t as well. So that will produce us 0.077 and 3.027. Okay, so the n-deriv feature. Part B, write the equation of the tangent line to the curve at the point where t is equal to 2. So again, equation of the tangent line. All we need is the ordered pair and the slope. So let's see, the ordered pair at t equals 2 is provided for us. Time t equals 2, the object is at position 1, 4, so there's our point. Our slope is simply going to be y prime of 2 over x prime of 2. Well, we already have y prime and x prime, so we simply just plug them in. So y prime of 2 will be cosine of 2 squared. X prime of 2 is t sine of t, so replace 2 in for t, we get 2 sine of 2. So we can either leave that as the slope, or we can evaluate that further and get a decimal of 0.359. Okay. Y minus y sub 1 is equal to slope times x minus x sub 1. Part C, find the speed of the object. So speed of the object is the absolute value of the velocity vector. So we simply follow our formula here, which is square root of x prime of t squared plus y prime of t squared. We want to evaluate the speed at t equals 2, so plug in 2 in for x prime of t and for y prime of t. We get square root of 2 sine of 2 squared plus cosine of 4 squared. Find the sum of that and take the square root. We get into 1.932. Next part, find the displacement of the object from 2 to 7. So displacement is simply going to be the definite integral of x prime of t dt. So displacement of x and the displacement of y, we're going to find those two separately. So the displacement of x will be, we can use the Fn integral feature in our calculator. We'll get negative 6.361, and displacement of y will be y prime of t dt, evaluated from 2 to 7, so therefore 0.096. So we can write this with the notation here of negative 6.361, and then the second component as 0.096. All right. Find the distance traveled. So distance traveled is simply going to be the arc length. So square root of x prime of t squared plus y prime of t squared, and then we evaluate, take the integral from 2 to 7, and we enter that in our calculator, and that will give us 13.229. Okay, next part, find the position of the object at time t is equal to 1. So if we want to find the final position, so we need to think about this. To find the final position, we need to know where our starting point is, our initial position, plus the displacement. So remember, displacement is the net change in position. So our final position at time t equals 1, we're trying to find our components, our horizontal and vertical displacement or position, which is x of 1 and y sub 1. This is our goal. So to get to from x of 1 and to y sub 1, we need to have a starting point. So the starting point that's provided for us is that at time t equals 2, the object is at position x value of 1 and y value of 4. So if I want to get from my starting position x of 2 to my end position of 1, I need to go backwards. So the definite integral from 2 to 1 of x prime of t would be the displacement will be the net change in position that I'm going to have to take. That will take me back to x of 1. Okay, so x of 2 we know is 1 plus the definite integral from 2 to 1 of x prime of t. So that will take us back to our initial position, x value of negative 0.440. And then y sub 1, we can take find y of 2, which is 4, plus the definite integral from 2 to 1 of y prime of t. We use our calculator, the Fn integral feature, and that will take us to 4.443. So our final position will be negative 0.440 and 4.443.